My name is Michael Calkins and I'm recording this flow of energy video for Microbiology 205. This video describes the flow of energy from glucose molecule to ATP. I'll be discussing and comparing ATP produced by aerobic respiration and by fermentation. Let's get into it. In aerobic respiration, oxygen is required and electrons are the energy that flows between processes, and hydrogen is the form that those electrons take. So aerobic respiration, however, starts with glucose, a simple sugar that we get from eating foods, which has 6 CH bonds. These carbon hydrogen bonds. These CH bonds are broken down in a catabolic reaction, and the energy released is in the form of electrons, that we see as hydrogen. And we can follow that hydrogen through this process. These electrons are then carried to the electron transport chain, or ETC, via carriers such as NADH. The flow of energy goes from CH bonds and glucose, broken down into electrons via glycolysis, which then leads to the TCA, or the Krebs cycle, and then to oxidative phosphorylation, or the ETC, or electron transport chain. Electrons are the way that energy gets passed along, gets transferred between these different processes, and oxygen is the final electron acceptor. ATP production in aerobic respiration is high, creating 38 ATPs per glucose molecule. That's huge. Now let's talk about fermentation. Fermentation is a non-oxygen requiring pathway only in prokaryotes for breaking the CH bonds and glucose into ATP. The main process in fermentation, however, is glycolysis. And again, the energy from the CH bonds, the carbon-hydrogen bonds, are converted into electrons, again via that hydrogen atom. The glucose is broken down into pyruvate, but since there is no ETC in fermentation, the NADH produced by glycolysis has nowhere to donate its electrons to turn back into NAD, which it needs to do. So, prokaryotes have 2 ways to regenerate NADH to NAD. One way is lactic acid fermentation, and the NADH transfers its electrons directly to pyruvate, generating lactic acid or lactate. NADH giving its electrons to pyruvate to make lactate is what generates NAD, again to accept more electrons. Another way, in alcohol fermentation, the process is similar, but for the NAD regeneration step, alcohol fermentation is a 2-step process. First, a carboxyl group is removed from pyruvate and given off as CO2, which produces acetaldehyde. Second, NADH passes electrons to acetaldehyde, generating NAD and forming ethanol. So, thanks for the wine. Drink up. Fermentation produces only 2 ATP molecules per glucose, which is a tiny fraction of the amount generated by aerobic respiration, which is 38. So thanks so much for watching. Again, this was Michael Calkins telling you all about fermentation and aerobic respiration.